Okay, let's go for section 5.7 now. We are going to work on division of polynomials. I'm going to split this one in two. I'm going to do the first video talking about just simple division of polynomials, two quick examples, then I'll cut it and we'll spend another video talking about long division of polynomials. So for example 1, they just want us to understand that we're treating this like separate fractions in a sense. Everything in the numerator can be divided by the denominator. So when we have items up in the numerator, we're kind of working backward from what we just learned. The first sections we were trying to condense everything and get one denominator, find the LCD. In a sense, we can think of this as the end result from then when we were trying to figure out how to combine them all with one denominator. So what we want to think now, you don't have to do this every time, but the thought process we use is taking 10x to the 5th over 5x squared, then subtracting 15x to the 4th over 5x squared, and then adding 20x cubed over 5x squared. Had we taken all three of these and gotten 5x squared in the denominator, we would have just combined the numerators. That's what we were doing in the first few sections. But now we kind of think backward of that. For division, this 5 can go into any of these because we can split it apart. So we'll think of this piece first. My 5 goes into my 10 twice. X squared goes into x to the 5th, and it leaves me with 3. That means this first piece, that divides evenly. My denominator is gone in that first piece. 2x cubed is what's left. Then I'm subtracting 15 divided by 5, which is 3, and x to the 4th divided by x squared. 2 goes into 4 2 times, leaves me with 2 of them. I can get 1x squared out, and I'm left with an x squared, basically. So I'm left with 3x squared. Then here, my 5 goes into my 20 4 times, and then I have an x squared and an x cubed. Now remember what I talked about a while back. When we have variables with exponents on the top and bottom, all we have to do is take the difference and leave the answer where the bigger one is. Here, the bigger one's up top. The difference of 3 and 2 is 1. So I leave it there. So what I actually have is 2x cubed minus 3x squared plus 4x. Yes, I could factor out an x, but I don't believe the book wants us to go that far. The book just wants us to end right here. They just want us to know what to do. How do we simplify this? Like this. We just whittle away to see what the denominator does with each one of the numerators. We can treat them as 3 separate fractions. You don't have to write it out like that every time. You can, that's the thought process we use. I just wanted you to know what thought process we use. Actually, you can take this 5 and see which ones it goes into. Get rid of that. You can take the x squared, see which ones it goes into. Now, if it doesn't divide evenly, you're left with a fraction, but you can keep whatever divides evenly, keep it off by itself. So let's go to example 4. I think, yeah, example 4. We'll do this one because now they gave us something a little more complex as far as they give us a full quantity in the bottom, x plus y. So when they give us x plus y, the key here, once we get something like this, again, I could treat it like x squared over x plus y, 6x squared. I could do that, but when I have a full polynomial up there, I first want to see if I can factor it out. Because if I can factor it out, I might be able to divide something evenly. I need to figure out what pieces I'm dealing with up here. So I have an x squared. This is going to happen whenever you have an x squared or a common factor you can pull out. So I have an x and an x. Here I'm dealing with a 7 and a 6. The y is insignificant. Because it's squared, you just know you're going to end with a y. There's going to be a y and a y, and an x and an x. Now we deal with just our numbers, our 7 and our 6. So we have a -7 and a +1. That'll give us a difference of -6, and it'll give us -7 multiplied together. Put that over x plus y. Now, I'm just going to rewrite it to clean it up since this is a short video. What we have, you never have to write the 1. What we have is this piece. Now, since these are multiplied together, we're not thinking in terms of 3 different fractions, we're thinking of one fraction. Right here it is. My denominator divides evenly into this piece, and it leaves me with x minus 7y for an answer. So, when you have a polynomial, you got to factor it. When you have just a string of common terms, then you want to treat them like they're separate and just see what does the denominator go into, what does it divide evenly into. So this one we had to factor out, and then you see it right there. That's how many times x plus y goes into that piece. All right, that was it. Now I'll come back with the second half of this where we talk long division. It's a little more complex, but there's really only one major thought process to use. All right, see you in a bit.